Hello, this is Dr. Ryan Johnson with the course Introduction to Statistics, and this is section 2.4, What Impacts Strength of Evidence? So for the reading, you should have read about the situation of this study that looked at if people tend to, if the person who tends to look more competent seems to win more elections. And you went through all of that, and now for the worksheet, we're going to look at another like one-on-one situation, but in this case, just looking at Olympics and some the combat sports of like boxing, taekwondo, Greco-Roman wrestling, and freestyle wrestling, and whether or not red or blue, wearing the red or blue uniform tends to matter. And so when we look at number one here, what are the observational units? What is the variable measured? What is the variable categorical or quantitative? That should be really similar to the first multiple choice questions you got asked in the reading. So hopefully you're able to kind of do one-to-one there and figure that out. And then you're asked in number two to state the null and alternative hypothesis in words. And so then this goes back to what we've already been doing last time. And so again, you can see that the null and alternative hypothesis were stated in the reading. And so you just need to state it now for this situation here. And then for number four, researchers Hill and Barton used data collected on the results of 457 matches and found that the competitor wearing red won 248 times. So whenever we've got numbers here, some of these numbers are going to be important. So 457 matches, red won 248 times, blue won 209 times. We're going to carry out a simulation to assess whether or not the observed data provide evidence in support of the research conjecture. So remember, we're doing our 3S strategy, which is S is for statistic, S is for simulate, and S is for strength of evidence. Okay, so then A, B, and C, we're going to do that. So then A, what is the statistic we will use? So that's the easier one. Okay, now describe how you could use a coin to develop a null distribution to test our hypothesis. So in that case, you need to give me enough details of like what you're doing with the coin flip, similar to other homework problems that you've been assigned, or other reading things we were assigned you went through that did that sort of thing. Then we're going to use the one proportion applet to test our hypothesis. So again, that is linked as a footnote, and also you can get to it on Canvas under student resources, applets, one proportion applet. And so then I've already got it pulled up right here. In this case, if the null hypothesis were true, then the probability of the winner of the match being a particular color would be 50-50, because color ought not to matter according to the null hypothesis. And so then we need to do number of tosses would be, say, 457, and then we would do depends on how powerful your computer is. If you've just got a pretty simple one, do 1,000, but another 0 always makes it better. Don't show the animation. And so if we draw the samples there, we're going to there. And so then now, here, I could do this as a number of heads, but I'm going to pull up a calculator and do 248 divided by 457 and get 0.542 0.54267. 0.54267. Okay. Also write down the mean and standard deviation from your null distribution and the proportion. So then summary statistics gives me the mean and standard deviation of the null distribution. Okay. So the proportion is used. You'll need this later. All right, we'll need those later. So write those down. Okay, so one-sided versus two-sided tests. Okay, so we're looking at a couple different things that affect the strength of evidence. And so here, one-sided versus two-sided tests. So a one-sided test is going to have, if you were writing symbols, would have this or that, a greater than or less than symbol. A two-sided test, that's missing there. That would have been not equals. So let's think about what a two-sided, like, I guess you're wondering why even do a two-sided test. So suppose researchers do not necessarily think red would win more often, but they also didn't necessarily think that blue would win more often. I'm just interested in whether one color would win more often than the other. So a two-sided hypothesis allows researchers to be less sure of the anticipated value. And that's often good because as a hypothesis, you don't often know which way the relation might be. So for number 5, if we let pi equal the probability that the competitor wearing a red uniform wins, state the hypotheses for the study in symbols using a two-sided hypothesis. So that means your HA should contain there should be a not equals in your alternative hypothesis somewhere. Okay. And there should be an equal sign in your null hypothesis. So number 6, return to the one proportion applet to approximate the p-value for our original overall proportion of red winning 248 times out of 457 matches. But now select the two-sided checkbox to find the two-sided p-value. So here our p-value is about 0.036, but then I'd go two-sided, and then it measures the other half too, and it's 0.066. So I think I was, yes, okay. Let me even do what the worksheet recommends, 0.543. Okay. So then go to that same distance to the left. What is comparable value? So the comparable value is 0.4548, being like the same distance from the null value, but on the other side. Complete the following sentence. The two-sided p-value of blank, so that should be the p-value, the proportion of repetitions I'm getting, is the probability of obtaining, that should be my sample size, or larger, plus a probability of obtaining my statistic, or larger, plus the probability of obtaining the opposite statistic, the one on the other side of null value, or smaller if the null hypothesis is true. Okay? You should have seen that when the alternative hypothesis is two-sided, the p-value is computed by looking at how extreme the observed data is in both tails. This makes the p-value about twice as large. So because of this, explain how switching from one-sided to a two-sided test influences the strength of evidence against the null. So, meaning, like, how does deciding go two-sided change that p-value? And what does that change in p-value? How does that change in p-value change the way you make decisions? So for instance, when I'm one-sided, I have strong evidence against the null hypothesis. But when I'm a two-sided, I'm now greater than 5%. So now I have only moderate evidence against the null hypothesis. So what happened? Okay, explain that difference. So for number 7, make sure to use full sentences, by the way, in your explanation. Number 7, we're changing to another way that strength of evidence is affected. And that's because that's the difference between statistic and null hypothesis parameter value. So a second factor that influences the strength of evidence against the null is how far apart the observed sample statistic and the value of the parameter specified under the null hypothesis are. For this study, the null value was 0.5 and the observed value was about 0.543 or 54.3%. Suppose a larger proportion of competitors wearing red won their matches. So now we're going to do this study. At first was real life, and now we're going to do an imaginary one where 57% of people wearing red won. So go back to the applet and approximate the one-sided p-value. All right, so so then say 0.57, and then not two-sided. Count. And it's only 13. So that is very small. It's less than 0.01, so it's very strong evidence against the null hypothesis. Okay, so I've already kind of answered B for you. C, write a sentence explaining the relationship between the distance between the observed sample statistic and the value of the parameter specified in the null hypothesis. So your answer should be something in the form of, when the distance from the null value to the sample statistic is even larger than fill in the blank. Okay? So the key idea is the farther away the observed sample statistic is from the average value of the null distribution, the more evidence there is against the null hypothesis. Okay? Now the final idea is sample size. So the third factor that we look at that influences the strength of evidence against the null hypothesis is the sample size. As we said earlier, the data for this study came from 4 combat sports in the 2004 Olympics. One of those sports was boxing. The researchers found that out of 272 boxing matches, 150 of them were won by competitors wearing red. This proportion of 150 over 272 is 0.551, is similar to the overall proportion of times competitor won red of the 4. So let's see what the smaller sample, because we're only looking at one sport. So let's see what the smaller sample size does to the strength of evidence. Using one proportion applet to test the sample hypothesis as we originally did. So now instead of 457, we've only got 272. So let's draw samples. Now we've got a different scenario. And then instead of 0.57, it's 0.551. And so then I've got 0.0491. Okay. So then compare the null distribution generated in this case to the generated number 3. So you should have written down the mean and standard deviation from the last one. And so the mean and standard deviation, compare that to this one. So the mean should not have changed that much, but you should pay attention to the standard deviation, how that changed. What is your new p-value? So here's the new p-value. Is it larger or smaller than the original p-value for number 3? Explain why that makes sense. So the key there is, like in your answer, you need to explain why that makes sense. Write a sentence explaining the relationship between the sample size and the strength of evidence against the null hypothesis. So the key idea is, as the sample size increases and the value of the observed sample statistic stays the same, the strength of evidence against the null hypothesis increases. So this is getting at that common sense idea: the bigger your sample size, the better. But there's a numerical quality to this. Not only is there, we just say like it gets better, but we can hopefully say even more. Okay. All right, that completes section 2.4. And so we'll end this video here.